All right, in this lesson, we're going to be talking about graphing functions and how we can go about doing that. So we're going to be doing it with a table of values. And those are objective graph functions with the table of values. Now before that, we're going to be talking about input and output machines. And so when we think about equations, we can think about equations as input and output machines, the x values being our inputs and the y values being our outputs. Now, we can choose any value for our input and plug it into the equation, and we're going to go ahead and solve for our output. So we see our equation here as y equals negative 2x plus 5. We see our input as 4. It gets inputted, x is equal to 4, so that gets inputted for my x value. Notice how I'm using parentheses to do that. So negative 2 times 4 is negative 8. I dropped down my 5, and negative 8 plus 3, or negative 8 plus 5, is negative 3. So that y equals negative 3 is our output, and we would actually then write that as an ordered pair, 4 comma negative 3, which we could then plot, which is what we're going to do. All right, so functions, as we've said, functions are a relation where every input is has exactly one output. So if I plug in a number, I will just get one output. I'm not going to magically get two different outputs for the same input. That's not going to work. It won't be a function. So we're going to graph using a table of values. Our x values are going to be our inputs and the y values are outputs. So let's go ahead and use that one here. So we have y equals 3x minus 1. Now, we don't have any x values listed. Sometimes you will, sometimes you won't. On these ones, we don't, and so we want to go ahead and pick some x values. I would recommend always picking x equals 0. That's a very good number to pick. And then for most of our equations, we want to usually pick some numbers around 0 to work with. So I'm going to go ahead and pick negative 1, negative 2. I like using the ones just right around 0, so those are the ones I'm going to use. You can pick, again, different ones if you would like. So 0 is going to be plugged in. This is our first x value, so that is going to be plugged into my x. So 3 parentheses minus 1. So this is where originally my x value was, but now instead of x, I'm putting 0. 3 times 0 is 0, minus 1 is negative 1. So I have the coordinate pair. So that's my output. Negative 1 is my output, and my coordinate pair is 0, comma, negative 1. And next I do the same thing for negative 1. So 3 times negative 1 minus 1, that will give me negative 3 minus 1, which is negative 4. So I have negative 1 and negative 4. Do the same thing for negative 2. So that will be negative 6 minus 1 is negative 7. And 3 times 1 minus 1 will give me 3 minus 1, or 2. So 1 comma 2. And our last one, 3 times 2 minus 1 is 6 minus 1, which is 5. So 2 comma 5. All right, and we go ahead and we plot each of those. So 0, negative 1, so I have my first point down here. Just to remember that our x values go left and right. Our y values go up and down, so I start at my origin. My x is 0, so I do not need to go either left or right, but I go down 1. So negative 1, negative 4, so start at my origin, go left 1, and down 4. There's my next point. Negative 2, negative 7, so start at my origin, negative 2, down to 7. And I keep going. So 1's positive 1, positive 2, so right 1, up 2. Positive 2, positive 5, so right 2, up 5. And now I have all my points. We can kind of see that it's forming a straight line. So we go ahead and we connect it with a straight line. Okay? And that is graphing that function. So our next one here, we have y equals negative 4x minus 5. Done very similar to this one right here. So I'm going to leave that one for you to do in your notes. This number 2 here. I'm going to go ahead and do our next one here, y equals x squared minus 1. Alright, so since this one has a power, we'll still do it exactly the same way, but the power is going to throw some other curveballs at us, and we just want to make sure that we do it correctly. So again, let's pick some x values. I like 0, and again, I like the ones around 0, so I'm just going to do the same ones, negative 1, negative 2, 1, and 2. So I'm just going to go ahead and pick those. Again, you can pick pretty much any x value. Just know if you pick too big, you're probably going to have either a really, really big number that'll be far out of your graph, or a really, really small number that'll be far out of the graph. So like, could you do x equals 100? Sure. But that will probably give you over 1,000 when you actually get your answer. And that's going to be kind of hard to graph. Can it be done? Yes, but you'd have to have a much bigger graph than what we have right now. Alright, so let's go ahead and plug these in just like we did on that previous one here. We're going to plug each of our x values into each of these x values right there into the x that I have right here. Now just a reminder, all our x values, these are our domain values. Everything in there, and these are our range values. Just a reminder that that's what we know from our previous lessons there. Okay, so I'm going to go ahead and plug that into x. Right there. So again, using parentheses, 0 squared minus 1. Now remember, when we're squaring something, so x squared is the same as x times x. 3 squared is the same as 3 times 3, which is 9. Negative 4 squared is the same as negative 4 times negative 4, which that is positive 16. So this x, or 0 squared, is the same as 0 times 0, which is 0. Minus 1 is negative 1. So my coordinate pair is 0, negative 1. Alright, so the next one, negative 1 squared minus 1. That is going to be negative 1 times negative 1, which is positive 1 minus 1, which is 0. So negative 1, 0 is our next point. We keep going. So negative 2 squared minus 1, that equals negative 2 times negative 2 minus 1, which that will give me positive 4 minus 1, or 3. So negative 2 and 3. Keep going. 1 squared minus 1 is 1 times 1, which that is 1 minus 1, and that is 0. So positive 1 and 0. 2 squared minus 1 will be 2 times 2 minus 1, 4 minus 1, which is 3. 2, 3. All right, and those are our points, so we can go ahead and plot them now. Now, as you notice, some of our y values repeated. I have a negative 1. Okay, that one doesn't repeat, but we have a repeating 0, repeating 3, and that's okay. Remember, we can repeat in our range. We just can't repeat in our domain. And so let's go ahead and plot these. So I have 0, negative 1, left 1, 0, left 2 and 3, right 1, 0, right 2 and 3. So how does this look? I have these points here. Now, if you've never graphed one of these before, you might be inclined to do something like that. And if you've never done it before, I would completely understand it. But that is actually not the shape of this graph. This one actually comes down, it goes through that point, goes through that one, and it actually kind of curves. It's a curve as we go through. Okay, one thing that we're going to be talking about later in another lesson is linear versus nonlinear. Linear, if we see the name linear, a linear function, I see this word inside, line. These are going to give you straight lines, linear functions. This is not a straight line, so we would say that this is non-linear. Whereas the one that we did previously is a straight line, and so this is linear. Okay? And that's kind of what those two terms mean there. All right? So, and I'm just going to say this right now. Anytime you see x squared, and that is your highest power, is a power of 2, the shape of the graph is going to be this curve shape. And we actually call this curve shape a parabola. That is the name of that curve or U shape that we have there. Okay? And so just a little bit of vocabulary for that right there. Okay, so one more that we're going to do is going to be this one right here. We have 2 to the power of x. Again, something that's a little bit different. Now this one, we can use our calculator if we're doing negatives. We know how to do this if it's positive. So I'm going to actually pick values of 0, positive 1, positive 2. Let's do positive 3. And then we're going to try to see what happens when we have negative 1. All right, so we go ahead and we plug it in. X is actually in the power. So we need to make sure when we plug this in that we're writing it as a power. So 2 to the 0, because that's where my x was, and that's what my x value is right now. This one, if you've never seen what this does, you can always see what happens in a calculator. Let's actually pull up the calculator and see what happens. All right, so here's my calculator. Remember, we're looking at 2 to the 0. So I'm going to go ahead and put in 2. Let's see how this calculator works. So here's my power button right here, x to the y. So if you see something like that, that's what that means. And so this one's showing the little caret right here. That's also, remember, when we've typed, that indicates power. So 2 to the 0. Let's see what happens. That is equal to 1. What happens is that is always going to be the case. I can do 6 to the 0 power, and that's going to be equal to 1. I can do 8, 5, 2. I can put as many numbers in here as I want, in 0.5. And if I raise it to the 0 power, it's equal to 1. That is always going to be the case. It doesn't matter what I'm raising or what I have right here, what my base is. If my power is equal to 0, it's going to be 1. So let's go ahead and put that in our graph. So as we saw with the calculator, that is going to be equal to 1. And so I have my coordinate pair 0, 1. And then we go ahead and we continue. 2 to the first is the same as 2. So anything, if I raise it to the first power, is going to be itself. 3 to the first is 3. 4 to the first is 4. 952 to the first is, well, 952. So anything that we raise to the first is itself. So 1, 2. All right, 2 to the second. We just were doing powers in the previous one, so that's 2 times 2, or 4. So that's 2, 4. 2 to the third is going to be 2 times 2 times 2. But you have to be very careful with that. A lot of people want to say it's 6, but it's not. If I do 2 at a time, 2 times 2 is 4. Multiplied by another 2 is 8. So 3, 8. All right, now we get to our negatives. So we have 2 to the negative 1. A lot of people, since 2 to the 1 is 2, a lot of people want to say, well, wouldn't that be negative 2? And it's actually not. It's not negative 2. Let's go back to the calculator and see what we have. All right, so we're back at our calculator. We want to do 2 to the power of negative 1. Let's see. we have our negative 1. There we go. So 2 to the negative 1 power, it equals, it's actually 0.5. We start getting decimals. If I was to do 2 to this negative 2, I keep getting smaller and smaller decimals. 2 to negative 3, let's see, there we go. Again, even smaller. So as we increase the negative of our input, our answer, our y value, is going to be getting a smaller and smaller negative, and that's kind of what happens there. And what happens is that we actually will never get to 0, because this will just keep on getting smaller and smaller and smaller, but actually never reach 0, which is kind of interesting. So this we said was 0.5, which is the same as 1/2. So negative 1 and 0.5. All right, so let's go ahead and plot these. So 0 and 1, 1 and 2, 2 and 4, 3 and 8, and 1.5. And so we kind of see this curve here. Now, if you don't know what happens further, we can see, okay, I'm going to be curving. Looks like I'm curving and starting to go up really, really fast. We saw one of these type of functions when we had the table of values, which we were matching to our graphs. So this is going up really quickly. I'm actually going to redo the inside. There we go. And so a lot of times people want to say, okay, then it's going to kind of just do that, but it doesn't remember what we saw, that as we keep on getting more and more negative on our x values, our y value never actually reaches 0. It just keeps on getting smaller and smaller and smaller and smaller and smaller. And so what happens is it actually does something like that. It comes alongside the x-axis, it's really close to 0, but never actually reaches it. What happens here is we have something along my x-axis, and we usually indicate this with a dotted line, like so. We have something called an asymptote. Let's see if I can spell that correctly. Asymptote. I think that's how it is spelled. And what this is, an asymptote is an invisible line that the graph does not cross. In this case, y equals 0, or the x-axis is my asymptote, and this graph is not going to cross it. It's going to get very, very close, come alongside it, hug it pretty much right there, but it's never crosses that line. Okay? And that's how we graph number 4. So I do believe there are a few practice problems for you to do. So negative x squared and x cubed, and that will be the end of those notes. So go ahead and get those. I believe I gave you number 2 here, and practice problems 1 and 2. All right, practice problems 5 and 6 is what we have it there. It's practice problems 5 and 6, so 2, 5, and 6 you need to do on your own, and that will be the end of the notes.